Welcome to KMP Build, Episode 1. We are building MyEuroStatApp in the open, one real commit at a time, and today's commit is C7A49, cache convergence. Here is the problem it fixes. The population feature cache data in a flat SQLDelight table that only stores total population per country and year. So the moment you open the age cohort pyramid, its data was gone on every restart and had to be refetched. The tourism feature had its own flat table too, 3 rows per country and year to model residence type, plus a magic -1 sentinel for missing nights because the column was declared not, plus country labels and the seasonality heat map stuffed into mutable in-memory fields, guarded by a mutex thrown away the instant the process died. 2 features, 2 bespoke caches, 2 sets of bugs. Today we converge them into one shared abstraction. Look at the shape of the duplication before this commit. Population cache entity is a flat normalized table, 1 row per country, year and age bucket, but only age equals statio ever gets written, so cohorts never persist. Tourism cache entity is a residence toll table keyed by country code, year and residence, with a not null nights column that abuses -1 to mean no data, and the country names and heat map grid live only in memory. After this commit, both features write into a single new table, MultIDimCache entity, 1 row per query, holding an opaque JSON-blob plus a fetch timestamp. A generic class called JSON-blob cache of T sits on top of it, giving each feature a typed serializer-driven read and write path instead of a bespoke DAO. The duplication collapses into one shared, well-tested cache primitive. The new abstraction starts in core common with a small interface called blob cache store. It is deliberately storage agnostic. Get of a string key returns a nullable blob cache entry. Put takes a key, a JSON string, and an epoch milliseconds fetch timestamp, and delete by prefix removes every row whose key starts with a given prefix. That prefix operation is why the key layout matters. By convention, every key looks like feature :slice :vn params, so a whole feature or just one slice of it can be wiped in a single call, and the VN segment can be bumped whenever the serialized shape changes incompatibly. This interface has exactly 1 production implementation and 1 in-memory fake, which is what makes the feature repositories trivially testable. Sitting on top of blob cache store is JSON-blob cache of T, a typed facade that takes a K serializer of T and the Kotlin serialization JSON instance, configured with ignore unknown keys equals true. Its get function reads the raw entry from the store, then tries to decode the JSON into T. Here is the important design decision. If decoding throws because the JSON is corrupted, or because an app update changed the DTO shape, that exception is caught as an illegal argument exception, which is the supertype of serialization exception, and get simply returns null. A decode failure is treated exactly like a cache miss, never as a crash and never as a result that error surfacing in the UI. The stale, undecodable row then gets naturally overwritten the next time the network fetch succeeds. But does the mirror operation encode T to a string, hand it to the store with the fetch timestamp? The SQLDelight file multidimcache.square defines the table this all sits on, multidimcache entity, with a cache entity that's Koin nox ash JSON text column, and a fetched ux up, and a fetched at nox ep poc wells, no per feature columns, because the JSON blob absorbs whatever shape a feature needs. 4 queries right on top, select by key for point read, upsert as an insert or replace for point write, delete by key prefix using a like with a wildcard suffix for that feature wide wipe, and clear all for tests. Compare that to the old tourismcache.square file. This commit deletes 6 columns, a composite primary key across 3 fields, and a dedicated index. The blob table needs none of that, because the dimensionality lives inside the JSON, not in the schema. Adding a table to a SQLDelight schema is not enough on its own. Existing installs are already sitting on schema version 1, and Android SQLite driver or native SQLite driver only run schema.create on a brand new database file. So this commit adds migrations /1.squam, it creates MultiDimCache entity, and drops the now obsolete tourism cache entity, taking every upgrading install from schema version 1 to version 2. While touching this, the commit also fixes a real desktop bug. Database drive for factory.desktop.kt used to call JDBC SQLDelight ADBC Quiet driver and then unconditionally call updatabase.schema. .create on every launch, which crashed on the second launch with table already exists and could never run a migration at all. The fix passes the schema directly into the JDBC SQLite driver constructor, so the driver manages SQLite's user and the version itself, schema.create only on a fresh file, migrations on every existing one, on desktop too. Population repository in play now takes a new constructor parameter, cohort cache, typed as JSON-blob cache of population cache blob. The DTO carries both the time series and the full per country, per year cohort snapshots that used to vanish on restart. The observe function now checks 2 tiers. If the query needs cohorts, it tries the blob first, wrapped in safe fetch, so a storage failure just degrades to a miss instead of crashing the flow. A fresh blob hit fully satisfies the query because the blob carries snapshots, so it can return early. If the blob misses, it falls back to the legacy flat DAO, which only ever has total population rows and no cohorts, so a cohort query never stops there, it always continues on to revalidate against the network. The persist step now writes both tiers on every successful fetch, and the cohort cache key is deterministic, population : cohorts : v1, followed by the sorted, joined country codes and the year range. Tourism repository in play goes through the same transformation, but the before state was messier. TourismCache blob now carries points, country labels, and heat map cells together in one document, with every metric a genuinely nullable, long no more -1 sentinel, because JSON has real null. The old repository stashed country labels and the seasonality grid in 2 mutable fields behind the mutex, reset every time the process restarted. Now they simply live inside the blob and survive restarts like everything else. There is one subtle correctness fix here too when a fetch succeeds, but its seasonality call degrades to an empty grid. Fetch and persist merges forward the previous blob's labels and heat map instead of overwriting them with nothing. And the blob whose points list is empty is explicitly treated as a cache miss, not a fresh hit, otherwise an empty result would silently act as a 12-hour negative cache. Storing a JSON blob instead of normalized rows is a real trade-off, not a free win. On the plus side, one write captures an arbitrarily multidimensional shape, cohorts, heat map cells, labels, that would otherwise demand several joined tables. Ignore unknown keys means additive DTO changes across app versions still decode, and the versioned key prefix gives migration-free schema evolution, since bumping v1 to v2 just makes old rows quietly stop matching instead of requiring a SQLDelight migration. On the minus side, You give up SQL level filtering and joins inside the blob's own structure. You cannot ask SQLDelight to search across cohorts, only fetch the whole document. Every successful network, fetch rewrites the entire blob. There is no partial update, and the data layer has to maintain a serializable DTO that mirrors but stays separate from the domain model. Commit C7A749 touches 33 files, a new blob cache store pod, and JSON-blob cache of T in core command, a SQLDelight blob cache store bounding Koin in core database, the MultiDimCache.schema and its v1 to v2 migration, the desktop driver fix, and both feature population and feature tourism rewritten onto the shared abstraction net around 700 lines of bespoke caching code deleted. The test suite grew to match JSON blob cache round trip and corruption tests, cohort blob stale versus fresh emission ordering, failing store degradation for both features, empty blob revalidation, and a dedicated schema migration test. If you want to see every line of this for yourself, check out the commit directly and read it in your own editor.